Hey everyone, welcome to the OpenZFS leadership meeting. Looks like we have a few items on the agenda today. So let's jump right in. The first one is about branching 2.2. Someone was asking this because of, sounds like they want to get overlay FS support into a release. I do not have the answer to that. Looks like maybe Brian just joined. Did you hear that question?
Yeah, I did. Yeah, looking at branching for 2.2 is something we want to look at doing fairly soon. We do have a lot of stuff in the master branch that has been there for a while, including overlay support and some other features. Really, we just need a plan to wrap up that work and make sure it's in a good state and branch it. Make sure what we have is in there is what we really want, and then move forward with that. But I don't have an exact date for that, unfortunately.
Like, are we waiting for some specific features? Do you have released, or like what's the plan? Why not start it at any arbitrary point? Because FreeBSD here running on master, like nobody's screaming really. And I personally know, and I systems would like to see it ready sometime in spring when we need to work on create new branches for TrueNAS, both scale and core on Linux and FreeBSD. And it would be good if we could use 2.2 for that.
Yeah.
Just to...
There were a couple of features that we were trying to get in before tag. I know that we were really close on a bunch of them, but they didn't quite get there. Block cloning was one of them, was ready to go in pretty much. And maybe force pool exports was pretty close as well. And I wouldn't want to make a branch, until, well, if we made a branch, those features probably wouldn't end up in that branch, right? If we were to do it now. So I guess we should circle back and figure out if we think we can realistically get those done before branching, or if there's other stuff that people feel is absolutely critical that needs to be in there.
No, yeah, block cloning would definitely be a good thing, but maybe you could have you tried to talk to Pavel. What's his plans there?
Yeah,
I know he's working, at least that's what I heard, but I don't know how close is it.
I see Paul's on the call. Maybe you could answer for us.
Yeah. Paul, are you there? Maybe he stepped away.
Yes,
Yeah.
sorry.
Okay.
Yeah.
Okay, so so basically for me, the missing item was zero claim, because without zero claim we cannot really allow to block clone across data sets, and I think that's that would be bad. So but I will be able to get back to it probably in a couple, probably in a month, and finish it, because I'm currently working with on a different project with Alan, so I need to finish this one first. So so this is how it looks, I guess.
I guess it would require a separate feature, or would it be committed as is now to add claiming later with smaller change, hopefully.
Maybe. Well, one of the problems is that when I sit down to do zero claim, it might prove itself that we can simplify zero records, because my initial idea, well, the easiest way was to simply record in the ZIL ID of the objects we are cloning and ranges that we want to clone. But because of the cross datasets cloning, I decided to record in the ZIL BPs of the blocks we are cloning. But then, mostly because of your feedback, it turns out it's not really. It still can be racy. And because this is implemented that way, that we record BPs, then the replay code is different than the cloning code, and this is precedence because all the ZIL replay operations are basically the same operations that are used during normal operations, and block cloning was different in this regard. But if we can do that from ZIL claim, then maybe we could simplify ZIL records, and maybe this would allow us to use the exact same operation for cloning and for cloning replays when we replay cloning records. So once that's committed, it will be probably hard to change how the ZIL records look like, or you need to probably some compatibility for that.
Oh yes, that wouldn't be easy. I agree. Well, like for me, in months would work, but obviously there always wish to sincerely. Thank you.
Yeah, sounds like we're probably at least a couple of months out from that being integrated to the main branch.
Yeah, well, not sure. Sorry, I wasn't prepared for that, but I can talk to Alan and see if maybe the current project, if we could make room for this. So maybe I would be able to sit and work on this earlier if this is what 2.2 depends on, and that if this is something we would really want to have. Yeah, but with my current obligations, I cannot say it at this point if that would be possible.
All right, I mean, that's fine. It's just, it's good to get like as accurate of times as we can when we're trying to plan the next release. I don't think that, you know, I'm fine with you taking the time to get it right and not have to do like rework to rejigger things after it gets integrated. Brian, I don't know what your feelings are on that.
Yeah, I know this is I'd rather we do it right the first time, of course, too. Kind of goes without saying. It solves us a lot of trouble down the road. I do know that there's a lot of interest in this particular feature, though, and getting some kind of at least branch started for the 2.2 release. So I would personally be interested in, like, if we can get this merged in the next month or two, and then, cut a branch after that with whatever's in master now between now and then. I think that would be great if that's viable. If it's not, if you want 2.2 sooner, we could look into cutting something sooner without this feature.
I mean, I kind of feel like we're better off trying to cut a release every year and not worry too much about holding off to get more features in, especially for these like features that are like, they take a long time to develop. They've been in the works for years, and yeah, it might not get it in, it might not make it into 2.2, but there's a lot of other stuff that is in 2.2, and it would be nice to get that out to a release.
Yeah, I agree. The current, a lot of people are on the master branch and it's in good shape now. So there's nothing preventing us from branching at any time. And yeah, we could certainly, we're a little overdue for our yearly cadence. So I could see tagging a 2.2 now with, what's in master today that's well tested and works well. And then, maybe we get a 2.3 at the end of the year or whatever with this.
Yeah, I think that like assuming that we have kind of the resources to be able to do one release a year, then I think that it makes sense to try and stick close to that.
Mm-hmm.
But obviously, like the decision goes to the people who are doing the work, which is not me in this case.
Yeah,
So,
well, there's there's other interests in making a 2.2 from just a maintenance standpoint, right? Like backports are getting more and more difficult, right, as the code base moves more and more forward. So there's good reasons to make a, at least start stabilizing a 2.2 branch off master for people to really test.
Yeah, I mean, it'll take probably a month or a couple months to go from cutting that first branch to having the final release, right?
Yeah, I would think so.
Yeah. All right. Other thoughts on 2.2? All right. The next item on the agenda looks like somebody crossed it out, but it was spurious EIO. This bug that was filed. I'm guessing it was crossed out because I opened a PR that will hopefully address this. So hopefully that will address the problem that is being seen there. I'm not sure what. Is there anything that we want to discuss about that at today's meeting?
I don't think so. So this was a bug in 2.18 due to a backport, just to be clear. We immediately rolled to 2.19 with that patch reverted. So, unless you're running the master branch at the moment, which still has this code in there until we merge your pull request, Matt, things should not be an issue anymore for people running the stable releases. And I think we only had a couple reports of it, so it was.
Yeah, and the reports did not have a lot of data, unfortunately. But
No.
so it's hard. I can't say 100% that the problem I'm fixing is this problem, but it's I'm fixing a problem where you can get this spurious EIO when you're using encryption and you have ganging. So hopefully this is what folks have seen. All right. Next item was one that we talked about briefly last time, but now the submitter is here. Rob wanted to talk about his PR to add chacha 20 as an encryption algorithm. He wants to find out what are the next steps for moving the PR forward.
Hi, yeah, that's me. I don't have a lot to say about it. It's kind of doesn't really touch the guts of ZFS much, other than to pipe through the cipher name for the encryption property. On FreeBSD, it just goes straight to the kernel crypto. And on Linux, I've implemented a module for the ICP to do the work, because Illumos don't have those algorithms in their tree. So the actual cipher stuff I've taken off the shelf. So it's kind of all there. It's all written up in the PR. So I mostly just need guidance on where do I take it from here. Probably maybe the tricky decision is deciding if, how do we decide if the crypto is good? It can have all the right words on the packet, but if it doesn't actually protect the data, there's not a lot of point. The reason for wanting this is just for devices that do not have hardware accelerated AES. It's very slow in software. So that's your Raspberry Pi, but that's also, there's a RISC-V board that I'm working with, which does not. So I would like a decent encryption option for that. So yeah, I'm just looking for guidance and assistance, or however we play this. Or a suggestion of where to go, who else to ask. If I know that it's a little bit weird work. So sorry, go, Matt.
Yeah, I was just going to say, I think we would probably want feedback from somebody else who wants this. Like, I think I understand, the use case that you're talking about. It makes sense theoretically. It would be good to have like other examples of people kind of like upvoting this, like, yeah, like I would totally use this if it goes in. And then I don't think we're gonna review the cryptographic code. I don't think we really have the skills or time to do that. It sounds like you basically copied it from like the reference implementation. So I think we'll kind of trust them unless anybody knows otherwise. And so then we need somebody to review, the kind of ZFS specific bits of this, which it looks like are not very substantial. We would need someone to review like maybe the man page, maybe like suggest adding some wording to the man page to, say when you might want to use this. But it looks like it's pretty light in terms of changes to the main ZFS code, which is really nice.
The only thing is that crossed my mind, since there are two different crypto implementation, maybe it could be cross-tested between FreeBSD and Linux to make sure it's compatible just in case. Like, sure, like it's same algorithm and should work, but
I've done only the most lightest of testing, which is making sure I can create a pull on one and import on the other. I have not gone further than that. I should do a little more extensive testing, but I can do some sends and receives and bits and pieces. But I don't know how deep that needs to go to feel sort of confident with it. Making notes of things to do.
What thoughts do other folks have? Oh, sorry. Unmute. I guess we'll leave it for you to work with other folks, find other people who are interested, find someone to review it. I think I didn't already assign Mark. I think Mark would be the assignee. Mark maybe. So he can also help work with you to find code reviewers. Looks like Jorgen took at least somewhat of a look at it. So maybe we Jorgen, how thoroughly did you look at this?
I went through it. I mean, I was pleased to see that it was written for ICP, so it will just compile for both Windows and Mac OS. So like I was mostly concerned about that. But the implementations look pretty straightforward and simple. And if you run OpenSSL, you can be given chacha. So I wasn't too worried about whether or not it's considered real. So yeah, it seemed fine to me.
So you looked at all the ZFS code.
Yep. Yep.
All right, great. Well, I
And
think,
I took a look at there's a GitHub for Chacha where it lists all the implementations, so you can get a feel for the C version and the assembly version.
cool. Well, it sounds like you've got one thorough review there, so that's a big step.
Mm.
And it looks like there's, the other folks that commented, Richard and Loop Violent.
That's the author of the crypto library in use. He's been filling
Okay.
us with some false positives that came through a static analysis tool.
Cool. Yeah. Are those conversations resolved now, or are you still discussing with them?
The one part we're looking at in there, it's not resolved. From the OpenZFS end, and there's a particularly gnarly piece of math that a static analysis checker tripped on that it said this could overflow, and it can't overflow because there is earlier checks in the code that ensure that can't happen. So there was some discussion about like, how do we actually prove that this thing works? So it's one of those things like, if the off-the-shelf implementation of the algorithm is good, then it's not a problem for us. The conversation is about whether or not it's good and whether, and so that sort of speaks to like, how much do we have to trust the thing before it's fine? So there's nothing for us to do on that. But I'm not really qualified to say like, yeah, this isn't a problem. It's sort of that kind of safety thing. So, but that's that conversation. There's no others.
Yeah. But it looks like you got like the original author of that code, kind of weighed in and said, I think that this is correct and that it doesn't actually overflow in practice.
Yeah, he's written sort of a like an English proof, and he's tried to write an automated proof of his, because he's very interested in making sure it's fine. Which is part of why I like this implementation, because he's very responsive and communicates very clearly about it. So, so yeah.
I mean, that sounds like a pretty reasonable answer to me.
I thought so too. So that's good. All right. No, that's great. I've got plenty to move on with now.
Okay.
And yeah, thank you, Jürgen, for your review. I hadn't realized you'd done a more complete review, so I really appreciate that. And yeah, I appreciate your time. I will come back to you soon.
Cool. Thanks
I have a question. Actually.
Oh, go ahead.
Oh yeah, sure.
I know that one of your primary goals in this is to provide something that's significantly more performant on things that don't get to play with the AES instructions in the sandbox. I was wondering, I'm not familiar enough to know, but are there accelerated versions of Chacha 20, Poly 1305 for things like SSE or AVX or whatever you like, that might be useful for getting even faster performance on systems that might have those anyway?
Yes,
Or not.
there are. There are. I haven't looked very closely at them, mostly because I don't read AVX straight off the top of my head. But I thought once the structure is in there and there's a generic implementation, I would like to look more at accelerated versions, particularly for small ARM processors, which is still crap on even in software. It's just less crap than AES, but if I could get an accelerated version there. But I thought, yeah, having the structure in place first and then extend further, but they definitely exist. Google has a lot of interest in these particular algorithms because this is what they're using on mid to low range phones that don't have hardware support for things. So the code's there.
Cool. Well, thanks, Rob, for putting this together and pushing it forward.
No worries. Thank you all for your time. Really appreciate that.
Cool. The next item from the agenda is ZFS space calculations, raidz deflation. There was a issue raised with a big discussion about this. I think Brian and I and maybe some other folks were involved in that discussion. I don't know. Is the person who put this on the agenda here?
I am.
Cool.
The mic works.
So where did you want to go with this discussion today?
I didn't know if there were any additional questions. I know that based on the discussion so far, there were some other questions stemming from it. I know Alan had some, although is Alan on the call? I know there was a mention of possibly prototyping it and shaking it out and seeing, okay, what actually happens. You know, does anything go sideways or break anything or get some unexpected results of any potential change? But just my original take on this was I initially was trying to do some just pathfinding on my own use cases here and seeing what sort of compression I was getting on files, and I was seeing some numbers that really just didn't make any sense, and it ultimately traced all the way back to the root issue that I raised, just because my particular configuration, I was storing things way more efficiently than would have been for, you know, a 128K based deflate ratio. So
yeah.
I would imagine that might extend to confusing other folks in the future, or anybody that has pools where, you know, the majority of their records or blocks being stored are more efficient than the 128K based math, which would then lead to some confusion because you end up with really weird looking things like the files appear smaller than they actually are.
Yeah.
You know.
Would you mind if I kind of take a stab at summarizing the issue for folks that aren't familiar with it?
Please.
So I mean, my understanding is that the concern is when you use raidz, you know, we have to allocate space for the parity, and the way that we display that so ZFS is like internally, it's keeping track of, you know, okay, I allocated, you know, you asked for 128K and I had to allocate, you know, that times 1.2 amount of sectors to have space for the parity. But the way we want to display it to users is like kind of sort of ignoring the parity, right? So at least like kind of in a lot of default uses, you know, you see if you add like 4 disks in a raidz 1, then like one of them is being used for parity. Like you can kind of think of it that way. So, you know, if you have 3 terabytes on these disks, then you show 3 terabytes available. And then, you know, as you use up space, it's like we're allocating space on all 4 disks, but then we're displaying a space used that's like assuming that you had 1 disk of parity and 2 disks and 3 disks of data. That's sort of the overall idea that we're talking about here. Now, the way that it's implemented in ZFS, we so first of all, like blocks, especially small blocks, can need more parity relative to the amount of data. So, you know, if you have a lot of small blocks, then we're like assuming this data to parity ratio, but that might not be true for your small blocks. And so the space used might be more than what you expect. But until recently, the space used was never going to be less than what you expect. So, but now that we have, so the assumption is based on, like the assumed ratio of data to parity is based on the record size of 128K. Now you can set the record size up to 16 megabytes, and those can be stored more efficiently. So, you know, you might see this like this weird thing where, you know, you have like your 4 disks, one of them is parity, and you're storing stuff with record size 16 meg, and actually you get to store like more you don't get to store 3 terabytes of data, but you get to store more than what it said you could, right? It's like when we calculated that ratio, we didn't say, oh, you're going to get 3 terabytes. It was like, you're going to get 2.8 terabytes of data, but then actually you get like 2.99 because you got more, because you used record size 16 meg, which is more efficient. I agree that that is kind of weird and confusing potentially. And I think it would be reasonable to try to correct that by changing the like best case ratio of data to parity to reflect the actual best case now of 16 meg blocks, or maybe a theoretical best case of like it is 3 to 1, like, you know, it is exactly 3 to 1 regardless of, you know, whatever. That's the absolute best case possible. I think that's kind of an implementation detail, especially since like record size 16 meg is the biggest that we're probably going to ever have, because we don't have more bits to store bigger, you know, sizes. And you know, practically speaking, the difference is going to be negligible. So the question is, there's kind of 2 questions. One is, do people think this is a good idea? Like, does that semantic make sense to say, yeah, like the default record size is still 128K. If you go in there with a default, it's going to say, you know, you have 3 terabytes available, but actually as you write uncompressed data, it uses up a little bit more than that. And so you end up only being able to put whatever it is, 2.8 or 2.9 terabytes of actual user data in there. I think that's probably okay. You know, obviously we already have that issue when you have compression, when you have, you know, zvols, which have a default record size of 16K. So it's like, in the default case, this is going to be a little bit more noticeable, which is like not great. It's a downside, but I think it's a minor downside compared to, you know, having that like fake ratio reflect kind of a best case scenario, rather than having people get confused about like, why is it using less space than it should, even though I'm not using compression, you know,
Right.
and then going down some rabbit hole of figuring this out.
I do have a note on that, and that is what you were just describing, where the user might notice some additional difference. They would only notice that change if they were using a suboptimal geometry before. In other words, if they had a raidz that only had 7 data disks, as an example, right? So that's obviously suboptimal for storing 128K stripes, right? So that configuration is one of those where you would see a few percent additional taken off of just the, you know, data versus parity, whatever that percentage would be purely, right? So that same use case, if that user had 8 data disks, before and after this change, they see no difference in that pool, because they didn't have any additional tacked on due to the padding for 128K, even in the former case, right? So this really only fixes it for those that end up in the weird, you know, these 128Ks don't fit properly, so we were taking some extra off, right? And then that was the biggest observation, or the biggest thing that sort of smacks you in the head from being on the wrong side of that is, yes, those larger records all appear much more, you know, they appear smaller than they're supposed to be, right? Than they actually are.
Yeah.
So whenever that number goes negative, that's where it just gets really confusing. At least my personal take, just because that's what.
Yeah.
I spent a good week trying to even get to the bottom of why are these files are. Initially, I thought 16 meg record size was leading to amazing compression. That's what originally got me here, was like, wow, look at how much better this is. I'm going to do this on everything. But then in reality, I started checking ZDB and realizing, no, that file only has like 2 compressed blocks out of 1 million. So this file is really not compressed, but it actually shows as if it was 8% smaller, just because of how the 128K would have had 8% more padding for my case, right?
Yeah, that makes sense. As you probably know, I'm not a fan of trying to game the width of your raidz things to like hyper optimize for these certain cases.
Right. And
but-
actually,
but
and actually,
your
this
point
is
still valid.
well, no, this actually reinforces your argument further, right? This makes it so that the free space calculation and everything else is more consistent, even for those cases that are not perfectly gamed, right? This lets you be more free to not have to game it. You got less side effects of just not worrying about the RAID Z and just setting, I mean, I have a personal pool here that's 88 wide. Trust me, I am absolutely not following the game the stripe width thing, right?
Yeah, so I think the first question for the group is like, does that seem like a better semantic than what we have now? And then the second question is going to be like, who is going to implement this and how? Which, that might have to wait for a later meeting. But first, why don't we see what thoughts other folks have about changing that semantic kind of, as a principle going forward. We don't know exactly how that's going to take effect. Maybe it won't affect existing pools, maybe it'll only affect new pools or whatever. But like as a principle, should we change the way that ratio is calculated to reflect more of an actual best case scenario now of record size 16 megs, even though the default record size is going to remain at 128K for the time being?
I had looked through some of the code. Again, this is really my first diving through the code base just over this issue. I've only done light dabbling in the past, but in some talking, or at least chatting with Alan earlier, and my own looking through the code, like it's anything above trying to make it the revision only take place for new pools turns into major surgery very quickly, right? You have one form of change. Yeah, you have one form of a change that is extremely simple to implement, in that you just change the default moving forward, and now only new pools it applies to, and all the old pools still have their old deflate ratio applied, right? Anything above that is a mess. There were two separate proposals that I had in there, and then due to some other concerns that Alan had, led me down a thought hole of, well, what if you make the default high so that you're covered and you don't end up with the weird, negative percentage issue, right? However, what if the user intended to make a pool primarily of zvols, for example? That pool, that free space reported initially is way off. Even with 128K, it doesn't matter. It's way off compared to what you can actually store there, right? If a technically inclined user knew, hey, this pool is just for zvols, why can't I just set it to what would correlate with 16K? If I know that all the zvols are 16K, that way that pool will always have an accurate free space reporting, unless of course you start filling 16 meg records or something on there, then all bets are off again, right? But that would be a little harder to implement, because you just need to give the user the ability to include, a customized value at pool creation. That would be the major, the additional change, right?
Right. Let's kind of ignore that for the moment and
Sure.
see if there's input on changing the way it's calculated to based on 16, like the best case scenario with 16 meg blocks.
Right, because that change is literally you change one number.
Alan, Brian, other folks who have already kind of seen that discussion, what do you guys think about that?
I definitely have concerns that changing it up will just mean that the estimates for anything with small blocks will get much worse. And if that leads to people running out of space a lot sooner than they thought, if zpool list says you're going to have this much space, and then you start writing it and that space goes down at 3 times the rate you were expecting, that'll seem weird. And I think that having it happen the other way, where, accidentally you ended up with more free space after you wrote, seems less problematic. But either way, the numbers are wrong, and that feels weird. So yeah, I don't know.
I think that the number, like the amount that we're talking about, is not 3x, right? Like we're talking about less than 10%. The difference between using the 128K assumption versus the 16 meg assumption, I mean, it's like single-digit percents, I'm pretty sure.
Right, but if you're using really small blocks on something,
sure, then you're already off by 3x, and
Yeah.
now we're talking about being off by 3.3x.
I suppose.
Right.
Right.
Yeah,
So
it's just a few extra
think-
percent.
yeah, I think that like the concern about being off by 3x is valid and not addressed and not addressed by this change and not made substantially worse.
Worse. Yeah.
By this idea.
Yeah.
So that's kind of why I
Mm-hmm.
feel like it would be okay. I also am like, hey, you get some extra free space, like, why are you complaining? But from a like understandability point of view, I think it does make sense, and that was the original intent, was to give you like a best case ratio.
Right. Like when Matt came up with that chart that was in his blog, the behavior was not actually matching the chart in the blog, right? If you change it to closer to either infinity effectively, like it goes away, or 16 meg, those numbers get a lot closer to the table in your blog. So for someone trying to look and go, okay, what am I going to fit on this pool?
The numbers in the blog take into account the record size, so they should be accurate. You're saying
No,
like
they don't account for the assumption of 128K for extra padding that goes into the calculation. In other words, the blog is assuming perfect parity, like you get that 3 versus 4. No,
that's not at all true. The blog is telling you exactly how much space will be allocated. This is before and not. It's kind of orthogonal to the ratio. The ratio is for display purposes only. It has nothing to do with how much space is like actually allocated.
right? No, yeah, I'm not saying that the amount of space actually allocated is incorrect in the blog. That math all checks out. What I'm saying is that if somebody were to look at that math and go, okay, I'm gonna pick this place because this is my use case, this is where I fit, so I'm gonna make my array based on that information, then their free space that they get right after they make the pool may be incorrect due to the extra padding, 128K, et cetera, right? Versus what they thought they might have gotten from
No, I
that
mean
configuration.
the reporting of that free space is inaccurate because they magically know that all the blocks that they're going to allocate are a certain size, but we have assumed that they're going to be 128K.
Right.
And so the padding and stuff works out differently.
Right. We're on the same wavelength. I'm just not using the right words. I apologize.
That's all right.
One more wrinkle I'd just throw out there is, while this is true for RAID Z, you can be quite a bit farther off with the DRAID configurations because they do add significantly more padding. So, it might not be 10%, it might be 20 or 30% you're off if you pick a really unfortunate geometry with really wide stripes. And right now
it goes, it changes it to multiples. As soon as you get beyond a 128K stripe, it doubles.
Yeah. And that's really confusing at the moment because it makes a very pessimistic estimate usually about how much space you're going to get in the pool. So we're under promising and over delivering a lot, which is
right.
led to some confusion.
So for DRAID, I think the common or recommended use case is probably to increase the record size, right?
Oh, for sure. Yeah.
Yeah.
I've looked, I haven't found where that math is. Again, I'm not fluent in the code base just yet, but like I was looking and couldn't find the dang thing. So I'm not sure where it's hiding.
The DRAID math is much less complicated. It's just like, when you configure DRAID, you configure the stripe width, right? You're like, I'm having 7 wide, like it's part of the configuration of how many disks are in the stripe. And so, we're allocating in stripe width times sector size increments. That's it. Right.
Right. Yeah. It just falls off this very sharp cliff as soon as you get past the data stripe being greater than 128K. Or less than 128K, sorry. Well, you know what I'm trying to say. Dang it.
If your data stripe is more than 128K, then like obviously you're always rounding up to that. So, if your data stripe is 256K wide because you have whatever that is, a lot of disks.
Right. If you go one disk past 128K, fitting properly, then your free space is cut in half.
That's not true. You
what
only
was
go up by 1 over whatever. So like 128K is 32 sectors, 32 4K sectors. So if you have 33, if your data drive width is 33 instead of 32, then you've lost 1/32 or 1/33, one disk worth of data is.
Right. Understood. I went back and looked at my numbers. If your A shift is 13 and you do that 32 data disk wide DRAID, your free space reported is cut in half. So maybe you have to be 256 wide for that to happen, and maybe that's a separate math issue happening somewhere. But like I was able to make a DRAID with 25% of the expected space by doing 64 data disks and an A shift of 13 or 14. Right.
Where have you found A shift of 13?
Right. A shift of 13 is 8K sectors, right?
Right. Yeah. I was not thinking it through correctly, or at least explaining it correctly before. It's that anything higher, if your actual data width goes beyond 128K, then it's just assuming you're pissing away whatever the remainder is, right?
Yeah, exactly.
So the higher you go, it starts to really, I mean, it's a large effect, right? It's not like single digit percentages. It's
yeah, I mean,
halving.
it's like if you're talking about 8K sectors, then your 128K block is 16 sectors wide.
Right.
So if you're going from 16 to 17, you're wasting, one drive worth, 1/17 of your data. If you're going from 16 to 32 wide, then you're wasting half of the data, half of the space.
Right. Even if the intended use case was just really huge records, and then you end up with your free space, you think the thing has half the capacity, but you can actually put twice as much on there. That's like really off, right?
Yeah. I mean, I don't know how common those use cases are.
Oh, I'm not arguing that's common at all. I'm saying eventually it'll probably start to happen with larger, with SSDs moving to larger physical sector sizes. And, I mean, I work at an SSD company. It's not inconceivable to get to an A shift of 15 soon, right? So you're going to start to get to the point where a reasonable width pool that's not obscenely wide is going to run into this issue, and then it would need to be addressed somehow at that point, right? So
yeah, I mean, it sounds like, especially because the recommended use of DRAID is with larger record size, it seems like basing the deflate ratio assumption on a larger record size makes even more sense for DRAID.
Right.
Does that make sense, Brian, or am I misunderstanding?
No, I think that makes good sense, and it's definitely the encouraged usage model. And it, helps with some of these worst case predictions. At the same time, like if you're actually using DRAID and not increasing the record size, and we're making these very optimistic predictions for you, could be surprised when you build your pool and it only, takes half the capacity you thought it would, right? So at the moment, it's kind of nice in that we're under promising and over delivering. I think it's probably like Alan's saying, maybe I don't like it, but maybe it's a better situation to be in if you find yourself there, rather than building something and discovering it's not quite big enough. We're kind of giving a worst case instead of a best case estimate, but
yeah, I mean, a better kind of place to be would be where the default record size matches the assumed record size, right?
When I incorrectly understood this, I assumed that the free space number was like the worst possible case, like if just what would be the most pathological one, and we use that to calculate it, and so we could never have less than that much space. But no, it's not.
No,
I mean, the worst case is you get 10% of the space or something, because there's all kinds of things that can go into it being much worse than it typically is.
Yeah, and the percentages on the worst side, even currently, go far deeper than the percentages on the opposite side, those negative values when your records are larger, right? Usually it's just a few percent the other way. It's just that those few percent are really head scratchers, right?
Yeah.
It's like, this file should not be smaller. How can this be smaller? It's not compressed, but it looks smaller, right?
Yeah, I mean, kind of what you're saying, Brian, is why I was thinking like, hey, maybe if we could increase the default record size and then increase the assumed record size to match the default, then, you know, there's less surprises about it using more space than expected.
I will say, having found myself on the wrong side of something trying to access a small SQL database that happened to be sitting in a data set that was a default 128K, even that was painful. So if you go much higher than that, you really fall off a cliff, right? It's a literal halving of the performance every time you go up another doubling of the default. So, you know, as much as I'm all for make all the things bigger, because I can't just fall into the trap of assuming that everybody's storing huge things. I just want the huge things to be reflected properly. That's my concern. But as far as the default goes, I don't know, anything over 128K is probably going to cause some heartache somewhere.
For people who are already encountering it, like for people who have already misconfigured it, you
Right.
know. Oh yeah.
Right. Yeah. I mean, if you really know what you're doing, obviously, okay, that's a database, 8K or 16K, do something, you know, have it in the right, on a properly configured data set, sure. But it helps to be able to cover those, the default.
Alexander, were you trying to get a word in there?
Oh, sorry.
Well, I think we just going in the loop several times. I was just saying, can we move on?
All right. Feedback from other folks. I think we've heard at least a bunch of opinions here, but more opinions are welcome.
I need to dig into it more. My question is, how much of the deflated numbers are we actually storing on disk, like in the accounting? And why would we ever store that versus, you know, reality of how much space it took, and then only have the free space be this calculation where we'd be able to change it on the fly without it messing up all the accounting on disk?
So you're talking about the implementation of like how you know, how could we implement this in a way that like gives us more flexibility?
Well,
Right?
just like, yeah, when we allocate some space and we're tracking that in the metadata and so on, what was behind the decision to use deflated values in there instead of actual, and only having that the deflated value be calculated kind of on the fly or the free space and not for allocated and so on?
I don't remember.
It was 20 years ago.
But I imagine it has to do with the fact that like a pool can be comprised of multiple top-level VDEVs, which each have their own deflate ratio. So when you have a piece of accounting that combines the space from multiple VDEVs, like say the space used by a file or the space used by a data set, then you know, there's no real way to combine those. You know, if you combine the base values without the deflate ratio applied, then you have no way to apply the deflate ratio after the fact.
Right.
In a
Which
accurate way.
proportion of the data is on this VDEV versus that VDEV and so on.
Yeah.
Okay.
So I think the way it's stored is like within each block pointer, it's the non-deflated values, but then in all the aggregate things like space used by file or space used
like
to a user or space used by a data set.
The data set ones, I think all those have the deflate, and that's why changing the value on an already existing pool will mess things up, because you'll now free that data and account for it in the new deflated value.
Right. And then I think even if you had a special alongside of a raidz, then if you're using a special small box, like if the file is on the special, then it gets reported with the full size as opposed to the corrected size, because it's not on the raidz.
All right. We only have a couple of minutes left, so let's go to the last agenda item. More adaptive arc eviction. Looks like there's a pull request.
Yes, that's my pull request. In my recent deep dive into Arc, among the other things I touched, I went to one more point, which is Arc eviction, which I found to be obsolete for many years because some of algorithms there actually predates ABD Arc and they're clearly broken. They're doing nothing. Arc like code attempts to evict unevictable blocks, but practice, truth is that those blocks are really not evictable. They're not even visible to the eviction code. It's just dead code doing nothing. And I trying to clean those. I also went deeper and tried to look on long-standing idea of making Arc balance between data and metadata natively instead of series of dirty hacks, half broken. We have now, for example, right now we have ghost state eviction, which always first evict data and then only start evicting metadata, which give us by design like broken balance between ghosts and then broken balance between data and metadata. So I clearly wiped out all of that code and written pretty small couple of functions from scratch, implementing just a balance between 4 different states, like data versus metadata and MRU MFU for data, MRU MFU for metadata, practically quadrant. Like I'd like people to take a look on that code. Actually, most of the patch, it doesn't look really scary. It's mostly mechanical addition to separately account for data and metadata that's required from us. Those changes are pretty trivial. And the only couple functions which are not trivial is arc evict and one function it calls from inside. It's literally 2 pages of code that's dramatically different, but it allows to remove so many dirty code from the ZFS, from the arc evictions that I'd really like it to be reviewed. I'm not saying that balance right now is perfect in the question of coefficients, what should be balanced between data and metadata, what should be rates of like adjustment with data versus like different states moving up and down, data metadata or MFU versus MRU. Some of them were just taken semi-randomly, but I tested it. Its logic is working, but some specific tuning may get some testing or for better ideas. But I'd like people to invite people to take a look on the logic I implemented there. Or is there any thoughts, opinions about that? As I've told, it's like 2 pages of code, which is really worth review. Other parts are mechanical ones. So significant change, but it's pretty small change in textual form.
That sounds really cool. So it sounds like you're balancing between data and metadata using a kind of like adaptive algorithm where it's like
exactly. I reuse the same mechanism of ghost states. I just introduced that there are now practically we always had 4 ghost states. Yeah. It's just were not widely announced, and as I told, they were not really properly handled. Eviction was broken between data and metadata ghost states. So I really formalized 4 different states: data MFU, data MRU, ghost MFU, metadata MRU, and the metadata MFU. Like it's really 4 different states with separate accounting, separate lists, separate everything. One downside is that I'm not exactly sure how to perfectly balance, like limit ghost states, because when there were 2 states, the size was always be equal to size of arc. If we have 4 states, that's slightly more tricky science from one direction. From one side, I'd like the total size to be size of arc, but from other perspective, I'd like to be like double size of arc, because I don't know in which way eviction will go. So I'm trying to, right now I'm taking approach of taking something in the middle. So we'll like question like if one of 4 states wish to use all arc, do we want to give it to it, or we want to go slowly? And well, my algorithm does something in between. Like if like you have hits like 90% distance off from the current point, it won't be a ghost hit. It will be a miss. Because like those hits may be irrelevant if other states also require some memory. So to perfectly handle that, it will require much more states. Okay, this heat was very close to recently, that was far, much more complicated mass. So so I try to take something in between. So something like maybe heat 75% of arc in the head will still be a heat, but if you go to 80 or about, it will be already missed. So it's but one of potential point of adjustments. But as I told, mass is pretty simple and clear, and it allowed me to remove few messy parts of the code. So I think if it would get some review and maybe comments, maybe testing to see how it behaves on real workloads, I think it would be good.
Yeah, I had a question for this. Looking at a customer workload recently, and they wanted the arc to mostly be metadata. And currently with the tunables they have, all they can do is limit what percent would be metadata, but they can't actually limit what percent would be data. With this change, can you control the maximum size of like the data MRU?
So I actually, with this patch, I removed most of hard limits like metadata minimum, metadata max. Yeah. I just completely removed all of that. I left only one knob tunable, which allows to specify how much metadata ghost hits is more important than data ghost hits. Generally, like if you set by default it's 5, just mostly random number. But if you set it to like 1,000, there's no upper limit. Then it practically means metadata will never be evicted. It means that as much as you have arc, like most of it will be metadata. Data will be on very minimal scale. Right now, I'm no longer measuring. One of more change there. I'm no longer measuring balances in like bytes between between MRU and FU before, but now I practically measure them in percents, fractional numbers. It's 32-bit fractional numbers. So it should be trivial to introduce limit to say, okay, we will balance between data and metadata never less than X, never higher than Y. It's trivial to add, but I just trying to be simple because previous logic of half dozen different knobs was just not working. And
I can back up Alexander there. I have an issue from a year and a half ago where I was seeing metadata being evicted when it shouldn't have, and arc meta min does effectively nothing. So the knobs that were there were broken anyway.
Yeah, I think this is a area that's long needed some work. So thanks a lot for putting something together, Alexander. Now we need to get some code reviewers.
Yep. Well, as I've told, like the only part that literally require review is like 1 or 2 screens of code. So I'd like people who've been there to take a look. That's not much really. Most of the PR is mechanical change, just to separate states.
Yeah, I think the tricky part is understanding like the dynamic behavior of the system given the code, right?
Yeah.
Like how do things actually end up balancing and making sure that we aren't introducing other bad behaviors where you get stuck with barely any of one of those 4 types of cache and then not being able to recover it.
Well, generally, if one cache is huge, it means other states will have huge ghosts. If there are any hits in those ghosts, they will quickly recover. I introduced the mechanism which slows down. Like if states going too low, it's actually like the reduction is slowing down. It's very difficult to get any states to 0. Like after 20%, 10%, it will get really slow.
Yeah,
so I will try to avoid.
It sounds great. It's just that's what code reviewers need to verify that it actually does that, right?
Yeah.
Which is hard to do, because it's like you're trying to figure out how the system will behave under certain inputs. But yeah, that sounds great. I saw you tagged me and George. I think we're good candidates to take a look at it. And maybe we can find some other folks as well.
I'd be happy.
Yeah. Cool. Well, we're over time, so let's call it a meeting. The next meeting will be in 4 weeks, and it'll be at the earlier time, 9 a.m. Pacific. All right. Thanks, everyone. See you
Thank
later.
you.
Thank you.
Thanks.